Hi, good morning. So today we are going to be doing an activity that goes over the three different types of tectonic plate boundaries. But before we do that, we're going to do a quick review over the two different types of tectonic plates. We have oceanic and we have continental. These two plates are very different. They're built differently, they're made out of different things, and they have different sizes. So for example, continental plates are extremely thick and they're not very dense, all right? They tend to be a lot thicker than the oceanic plates. These plates are very thin and that they are extremely dense. So this means that when an oceanic plate and a continental plate run into each other, the oceanic plate will go underneath the continental because it's more dense, so it sinks. And we're going to see that later on. These two plates are also made up of different materials. Oceanic is made out of things like basalt, which is found in most oceans, whereas continental is typically made up of granite. All right, continental, the easiest way to remember this is continent. Most of the continents are made up of continental plates, whereas the oceanic plates are found primarily in the oceans, such as the Pacific plate. So we're going to be going over the three different types of boundaries. We have convergent boundaries, divergent boundaries, and transform boundaries. So I'm going to show you how each type behave, and you are going to record what you see into your notes. So the first one we're going to go over are convergent, meaning that they are converging together. So we're going to do this by using models. So this is our model. It's a towel for our convergent plate. Okay, you can see it's a hand towel. It's pretty thick. That's our convergent plate. And for our oceanic plate, we are going to be using a manila folder. Very thin, okay? So our first example of a convergent plate boundary is when we have two continental plates converging together. So here I have my two continental plates, and I'm going to push the ends together with my hands, and we're going to see what happens as they are pushed together. So as I push these together, all right, the plates, all right, are rising up to meet each other. One is not sinking below or going above another. Instead, they are coming up like this. What type of landform do you think this is modeling? When two continents go head on, what looks like this in nature? All right, so that was continent on continent. Similar things happen when you put two oceanic plates converging on each other. All right, so in this case, we have our oceanic and our oceanic. If they were to do this, they're going to rise up. It's hard to do with paper. All right, but they're going to rise up and they're going to crest in the middle like that. It's very similar to the continental and continental. Now, we're going to see what happens when we take an oceanic plate and a continental plate. What do you think is going to happen when we take the thicker plate against the thinner plate? All right, so you have, so let's call this the Pacific plate versus the North American plate or the Eurasia plate. All right, and when they get pushed together, the continental plate goes right over the oceanic plate. There are two reasons for this. One, the continental plate is physically bigger, and also the oceanic plate is dense, all right? It's extremely dense. So when it hits, all right, the continental, it's going to sink below and melt into the mantle, all right? When it melts, all right, that magma begins to pool, and that is how volcanoes occur. This is called subduction. When a plate subducts or goes under another plate is called subduction. So there are three things that occur at convergent plate boundaries. We have mountains, we have volcanoes, and we have trenches. Trenches occur when subduction happens and you find a trench forms in between the two plates. There is a famous trench called the Marianas Trench, all right, and that is one of the deepest points in our ocean, and that was formed due to a convergent plate boundary. All right, so the next one is called divergent. Divergent means two plates that are pushing away from each other. In this case, we are going to be using the oceanic plates because one of the most famous divergent locations is in our ocean. So we have our two plates, our oceanic and our oceanic plate, and they are divergent, which means that due to convection currents, like we learned about on Thursday, all right, these plates are being pushed away from each other. Those convection currents occurring in the mantle are pushing these oceanic plates away from each other. This creates a space where new crust can be made because lava is going to pool underneath and come up and cool, and it's going to continue to build new crust as the plates move farther and farther apart. This is something called a ridge. The largest ridge is the Mid-Atlantic Ocean Ridge, which runs down the middle of the Atlantic Ocean, and it is constantly where new crust is forming. So this is the location where the new crust would be, and the older crust would be on the outside because new crust keeps forming and forming and forming and pushing that old crust away. So that is a divergent plate boundary. The last plate boundary that occurs is transform or transverse. And that occurs when two plates are pushed next to each other. Okay? The perfect example of this is in California, where you have the San Andreas Fault, where two plates are rubbing up against each other. All right, if you ask anybody in California, one of the most common occurrences that they have there of natural disasters are earthquakes. Why do you think there are earthquakes at a transform boundary? So I'm going to show you how that works. I have our two continental plates, all right? And when you have a transform boundary, these plates are pushing up against each other. So it's very common to have mountains in these locations. So they're pushing up against each other and they're moving very slowly against each other. Every time there's a small piece of movement is when an earthquake occurs. All right, so that is a transform. So they can bunch up like this to create mountains, and they create small faults, or in California's case, a very large fault where earthquakes occur very, very regularly. So those are our three different types of plate boundaries. Just to remind you, we have convergent, where two plates collide, divergent, where two plates separate, and transform or transverse, where two plates are rubbing up against each other. If you have any questions, let me know and we can clarify any of those.